Assalamualaikum warahmatullahi wabarakatuh. Now I would like to present introduction to Zener diode. First, what is a Zener diode? Zener diode is a type of semiconductor which allows current when flows in forwarding direction and also allows current to flow when in reverse direction. But there is a condition for reverse current. So here I would like to show the symbol of Zener diode and Zener diode itself. If the voltage is above a certain level only, then Zener diode will allow flowing a current in reverse direction, and this required voltage for reverse current to flow in Zener diode is known as the breakdown voltage. So what is the Zener breakdown voltage? Zener breakdown voltage, in simpler terms, let me tell you the basic operation of a semiconductor. Semiconductors have some unique properties, as I told you earlier. One of the properties is allowing current in one direction and blocking in the opposite direction. These two directions of current are known as forward biasing and reverse biasing. Forward biasing means current is flowing in the forward direction, and reverse biasing means it's flowing in reverse direction. So now I would like to show the graph or characteristic of Zener diode. This graph named as VI graph. It stands for voltage and current or current graph, where V represent voltage and I represent current. This graph shows what will be the voltage on a specific amount of current in a semiconductor or VISA. First, this V over I graph characteristic is different for different semiconductor. Let's have a look at how this graph will look in case of Zener diode. And second is graph of V over I for Zener diode. And if you study this graph a little bit in the right section, you will notice that after a certain point only current will increase and not voltage in forward bias. If you look at the reverse bias part, you will note the same kind of trend, but there is a negligible amount of current flows in reverse bias if you take a closer look. After a certain point of breakdown voltage can be increased further and current starts flowing. Lastly, I hope to share what are the advantage and disadvantage of Zener diode. First, I would like to share the advantage. There is 5 advantage, which is it's less expensive, it can be used to regulate voltage, it also can control the flowing current, it's compatible with most of the current of the circuits, and lastly, can easily work with smaller circuits that would not work with a high amount of current. And lastly, I would like to share the disadvantage. These are 2 disadvantages. First, Zener diode cancels out voltage by applying a high amount of voltage in reverse direction, which is a waste of electricity. And lastly, it's not as good as a transistor in performance. It's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nafidaus Petahi, number matric D5 D0520101040. So at this time I will present half part of the literature review of our assignment topic. So for the introduction, I had prepared a statement to our discuss in the introduction. So the statement is breakdown diode, or perhaps Zener diode as they are sometimes referred to, are essentially the same as the conventional p-n junction diode, although they are specifically designed to obtain a specified and low reverse breakdown voltage that uses any reverse voltage that is put on it. So for this statement, it is according to SEMA 2019. So for the second one, it is the literature review. So I have prepared 3 statements about the literature review of our topic and our assignment. So, according to Mitsuru Ura, 1988, a Zener diode with a low dynamic independence and a low leakage current consisting of the first layer of a single silicon crystalline semiconductor doped with an impurity of P-type or N-type, and the second layer of silicon artificial phase group doped with an impurity of the opposite type. So that's it for the first statement. So for the second statement, the discovered diode contains in one embodiment an anode region and a cathode region forming a shallow latitudinal subsurface junction. In addition, the Zener diode may include an anode contact region interconnecting the anode region with a contact located away from the region of the Zener junction and a structure of silicate blocking over the anode region. So for this statement, it is according to Wei Chen and 2015. So we will continue. The last statement or the third statement. The special Zener diode is exposed, which is shattered in the sequence of linked battery cells string across each cell. All battery current is routed through the looping element of the Zener diode in response to a cell failure that causes a cell to open the circuit. This current causes the looping element to adjust forever, thus allowing the looping element to become a permanent short circuit. The failed cell is thus eventually struck on the circuit. So, for this statement, it is according to Mori Almich 2005. So, that's all for my presentation about the literature review, the half of the literature review. So, another half of the literature review will be continued by my partner. So, that's all from me. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh to Dr. Imran and Dr. Faiz. My name is Muhammad Azmin Amir Shah Shahriman. We'll continue my partner Muhammad Nur Firdaus literature review, which is Zener diode. And here we go. A Zener diode having a surface adjoining first region of the first conductivity type. Excuse me. According to Albert Smith's 1983, a Zener diode having a surface adjoining first region of a first conductivity type, a second region of a second opposite conductivity type situated within the first region, and a third region of the first conductivity type which is situated at a distance from the surface and which is bounded entirely by the first and the second region and is more highly doped than the first region. The third region being overlapped by the second region on all sides. According to the invention, the first region comprises an epithelial layer which is provided on a more highly doped substrate. The third region is preferably bounded entirely by the second region and by the epithelial layer. The structure, according to the invention, provides reproducible breakdown voltages even in the case of series. Even in the case of series production from semiconductor wafers having a diameter of 76 mm and larger. Next, diode is well known for its ability to mm, sorry. According to my research, diode is well known for its ability to allow current to flow in one direction only, and when it is in reverse bias mode, it will not allow any of the electron or current to flow through it and into the circuit. It is no different with the Zener diode after all, but with only slight of twist, which is Zener diode stands out from the other diodes because it has specified reverse breakdown voltage, also known as the Zener voltage. It means that if the Zener diode is put into reverse bias mode, it will still preventing current from flowing, but up to a certain voltage. For example, if the If the Zener diode has a specific voltage breakdown of 15 volts and the circuit is currently provided with a 5 volts power supply, the current will not flow into the circuit after all. However, if we increase the voltage supply surpassing the Zener diode voltage breakdown, the current will eventually flow into the whole circuit. Next, the avalanche breakdown occurs in both of the normal diode and Zener diode, which when in high reverse bias voltage. When the PN junction of the diode is applied with a high voltage supply, the free electron will gain massive force of energy that will make it move with a high velocity and thus collides with other free moving electron. Due to this continuous collision, the electron will keep collide and knocks off another electron and will generate large number of electron moving as a result of electric current. This sudden change of the current will normally damaging the normal diode, but not the Zener diode, because the Zener diode is specified specifically built to sustain the spike of change of the electric current, and it is purposely to build for that and to operate under to operate normally under the avalanche breakdown and to sustain the sudden changing of the current. Right, next, this is the picture and symbol of the Zener diode. The Zener diode has a black line to it, as you can see here. Next, and for the most common specifications of diodes that I've saw through my research was Zener breakdown voltage. The reverse breakdown voltage ranges from 2 volt to 200 volt. Temperature stability around 5 volt. The diode have the best stability, and the voltage tolerance is generally plus minus 5%. Alright. The Zener diode is mostly used as a voltage regulator. The breakdown voltage of the Zener diode will be constant for a wide range of current. So throughout my research, this is my conclusion for literature review, which is, as we can see through all of the above, my verdict is the existence of the Zener diode has been a breakthrough in the human history. With that Zener diode, we can regulate or set the amount of voltage that is still safe to run through the entire circuit without damaging the diode and cause the shortcut to the circuit as well. It is a very useful and effective device that have been used everywhere in the world. We as a student also should learn about it and try to harness the great capability that the small Zener diode possessed. So we as a manufacturing student can try to think proactively and maybe create something very useful for everyone out of the Zener diode itself. Alright, that's all from me, Muhammad Azmin Amir Shah and Muhammad Nur Firdaus. We ended our literature review here. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khairun Jauhari bin Kamis, D0520101111. Today I want to conclude and discuss about the Zener diode. The diode is one of the basic components in electronic circuit. When you want to know about voltage consideration, you should know about the diode. The diode is basically made up of semiconductors, which have two characteristics, P-type and N-type. The P-type and N-type semiconductor represent positive and negative type semiconductor. P-type semiconductor will have excess amount of holes in configuration, and N-type semiconductor will have excess amount of electrons. If both type of characteristic present in a single circle crystal, then it can be termed as a diode. The positive terminal of the battery connect with the P side and the negative side is connected with the N side. Some of the more important factors in the design of a Zener reference circuit have come to light as a result of analysis and measurement of a particular circuit with judicious choice of circuit component. A very stable voltage reference may be obtained using a Zener diode as the reference element. Two of the three major sources of error, which is deviation from a constant voltage traceable to the national standard, are predictable and controllable.